Okay, welcome back. I hope my screen is visible.
Yes.
So today we will discuss about AWS load balancer and auto scaling. So this is a service that automatically distribute incoming traffic across multiple targets. For example, EC2. So if we have two different EC2, so user will be facing the load balancer, and it's the responsibility of load balancer to distributed traffic. For example, some of the instances are busy taking so many requests. So it will see that there is heavy load. So it will route the traffic to another instance. So this job is done by this service called as load balancer, as the name suggests, balancing the load of the traffic, incoming application traffic. So it can be also for two IP addresses or two different container or multiple containers in one or more availability zones. It can be all the instances are in same availability zone, or it can be across the availability zone. So it will route the traffic, distribute it to balance the load. What we will achieve, it will help us to improve the availability. If you have multiple availability zone, if you have created instances in different availability zone, it will help you to achieve the availability. If in case one availability zone gone down, your EC2 instance or application will be still running into another availability zone. So that way it will increase the availability. Fault tolerance also, any hardware, power, anything, any issues there, or VM itself is down, then it will help to route to the another one. And it will also improve the scalability, means more and more number of user can connect. So this was a very simple diagram. Users, they are least worried about where my application is, in which EC2, in which availability zone, in which region. They only just send the request and load balancer will do the traffic distribution. The following diagram shows the logical architecture with an example. For example, we have two different EC2 instances and we have a load balancer in between attached to distribute the traffic to your application. So one is in availability zone 1, other in availability zone 2, instance A and instance B. Both are in two different availability zones. So we have application load balancer inside the VPC, and user will be hitting the traffic to the application load balancer. So there are different type of load balancer in AWS. First is application load balancer, ALB. Second is network. Third is gateway. And fourth is classical load balancer. All has different purpose. So it is best for HTTP and HTTPS traffic. Network is for TCP and UDP traffic. Gateway is for deploying and managing third-party virtual appliances. Classic load balancer is a simple load balancing for EC2. Works at different OSI layer. So the key feature of application load balancer is host path-based routing. Path-based routing and network load balancer. Key feature is high performance, static IP, and TLS offloading. We'll discuss in detail. And gateway key feature is transparent traffic flow, inline inspection. The classic one is basic routing, not recommended for new one. This is for legacy or old applications. So here a cheat sheet to understand it in a simple way. So this classic one is basic load balancer for old app. What it does is for old apps. When to use it, simple website or app, older setup. When we have very legacy application or website, we can use this classic load balancer. It works at 4 and 7 network and app layer. we have 7 layer of OSI networking, right? So this worked at 4 and 7. Application load balancer, it routes web traffic smartly. So we will use it for website microservices and API pocket layer 7 application layer. It works at application layer. Right? The name suggests app load balancer works at application layer. This one network load balancer NLB works at network layer, which is layer 4. It is very super fast and it's a lot of traffic, high speed app and game when we want high speed apps and games and IoT. Gateway load balancer manages special network tools like firewalls when using network security appliance. So it will be in special cases when you want to use different network security related appliances, firewall or anything like that. So again, old school thing like basic balancing for HTTP and TCP, smart HTTP routing best for modern web apps and microservices, super fast low latency handle TCP/UDP best for high performance for scaling and managing network virtual appliances. If you want a smart website app traffic routing, use ALB, application load balancing. You need speed and can handle million of connection. You can use NLB. Classic is only if you have old app still using it. If you want to run network security tool inside AWS for network related tools, you can use gateway load balancing. So theoretically, let's see at least 2 EC2 instances running in different AZ. Here we have an example, 2 EC2 instance running in different zone. A VPC with public subnet, we need to have that because user will be connecting through the internet. So you have some public IP. So public subnet should be there. A security group for load balancer, we need that. And how to create application load balancer? Go to EC2 dashboard, go to load balancer and create a load balancer. Over there you can choose this. So let's go to console. You can see load balancer. So under EC2, you can see this instance, image, elastic block, network and security. Under that, you will see load balancing. In that, you have load balancer software. Simply click on EC2 and then scroll down. See this option on the left side, load balancing. So elastic load balancing scales your load balancer capacity automatically in response to changes in the incoming traffic. So as of now, we don't have any load balancer. We can create a load balancer. Compare and select load balancer type. A complete feature by feature comparison along with detailed highlight is also available. You can click here. So first is application, network, gateway, and classic one, previous generation. So we have total 4 load balancer. So they have given some pictorial representation. This is a user. This is your load balancer, application load balancer, which handle HTTPS traffic. And you have different services. So network load balancer, you need a VPC and you will have network load balancer, which will handle TCP UDP traffic. And then we have multiple instances. Only gateway, you will have some appliance, network or security appliance that will handle the traffic. This one is a classic previous generation old load balancer where you have an existing legacy application. So you can choose from that. So let's have this option, create. The application load balancer distributes incoming HTTP and HTTPS traffic across multiple targets such as instance, microservices, container, based on request attribute. When the load balancer receives a connection request, it evaluates the listener rule in priority order to determine which rule to apply and if applicable, select a target from the target rule. So here they have explained client make request to your application. This is a user or client. The listeners in your load balancer receive request matching the protocol and port that you have configured. So there would be a listener who will see what is configured, which protocol is allowed, which port is allowed, that you will configure. The receiving listener evaluate the incoming request against the rule you specify. So whatever rule is there, it will match it. And if applicable, routes the request to the appropriate target group. Right? You can use an HTTPS listener to offload the work of tails and decryption to a load balancer. Healthy target in one or more target group receive traffic based on load balancing algorithm and the routing rule you specify to the listener. So first of all, you should give the name. Name must be unique within your AWS account and can't be changed after load balancer is created. So you need to mention the name wisely. Application load balancer. Scheme can't be changed after the load balancer is created. Internet facing or internal. If you want for private routing, private internal routing, which is not having any public IP, then you should use internal. Maybe you have one database server and two application server. You want to route the traffic in between. You can use internal. You want for some web application traffic is coming from internet, you should use this internet facing. It serves internet facing traffic. It has public IP, DNS name to resolve the IP, and requires a public subnet also. It serves the internal only traffic. It has a private IP address only. DNS name is required, compatible with IPv4 and dual stack IP address. So you have these options. So go to here, give it a name and select the internet facing and choose IPv4. Select at least two public subnet in different WT zone. Configure the security group to allow the HTTP. Security group is like a firewall, right? We have discussed already, wherein you will allow port 80 for HTTP traffic. Set the listener as HTTP 80 and HTTPS traffic for 443. Create a target group, right? Choose instance or IP type. Register EC2 instance in the target group. Review and create a load balancer. So all these options you can see here. So first is give it a select which load balancer. I have selected application one. Which scheme, internet or internal? I will select internet facing. Which one? I will select IPv4. Load balancer IP address type. This would be the front end IP address type assigned to the load balancer. The VPC and subnet mapped to this load balancer must include the selected IP address type. Public IPv4 address have an additional cost. Always note, whenever you use the public IPv4 address, it will have an extra cost. So the load balancer routes traffic to target in the selected subnet and in accordance with your IP address settings. So VPC. So which VPC you want to create, you need to select. So IP pool, you can actually choose to configure an IP pool as first. Okay, I'm not going to choose this one. LT zone and subnet. Select at least two LT zone and a subnet for each zone. Why they're asking for two subnet? Because we want high availability. If in case one goes down, it will automatically route the traffic to another availability zone. So we have selected two availability zone. A security group is a set of firewall rules that control the traffic to your load balancer. Select an existing one or you can create also. So let's select the default one, no issues. Select a listener. A listener is a process that checks for connection requests using the port and protocol you configure. It is a process that check for connection request. And what it will validate? The port and the protocol. Protocol is HTTP and port is 80. Like that, we can configure. The rule that you define for a listener determine how the load balancer routes a request to its registered target. So we have to configure the protocol layer. So we can select the target or we can create a target also. We can add another listener. So first one was for HTTP port 80. Another one we can create for HTTPS, which is having default port 443. And we can select the target group where it should go. If anything comes via this port and this particular protocol, where it should go, what action it should take. So secure listener setting. You can, the setting will apply to all of your secure listeners. Once created, you can manage the setting per listener. Your load balancer uses security, secure socket layer negotiation. Okay, all this security thing is there. Let it be default. So here is the summary. We have given this name. We have provided internet facing IPv4. This is the VPC I have selected. The public IP is there. I have selected these two availability zone and I have configured this particular security group and I have uh, given these two listeners, these two process like HTTP and HTTPS, and I can select the target group also. So as of now, take it as default. So I can do one thing, create a target group. Let's see what an all option is there. So in the target group, you have to choose the instance. Create the instance and EC2 and then target groups. Your load balancer route the request to the targets in a target group and perform health check on the target. So here you are designing this particular application load balancer within this VPC and across two IoT zone into two different subnet, you can say. So you have created the listener, like on which port, which protocol user will send the request and it will validate it, but where it should go. Incoming, you have defined what action it should take on which instance. In your infra, you might have, let's say, you might have, for example, 100 instances, right? But not all instance is used for hosting the website or application. It would be for other department, for other work also. So you need to specify this particular application load balancer need to have a target where it should route the traffic, where you will be actually having your application hosted or website hosted. So it is your job to tell this application load balancer where to route the traffic, where it should go. So that's why we have to mention the target group, the instances. So here, once I click on create target group, it is asking me either instance, either IP address, or you can lambda function also, where we will run the function. We can post we can create the code for application or website. So target could be Lambda function also, or it can be another application or load balancer. You can give the target group a name, protocol, VPC in which it should be there, some health check. The associate load balancer periodically sends requests as per the setting below to the registered target to test their status. So whenever a traffic comes, it need to do the health check first to the target. Why? Because it should know the status, which one is live. Let's say this one is working fine, it goes down. Maybe for some reason, entire availability zone is not available, or OS is got corrupted, or network is having issue, or power failure, or anything like that. It will know in advance using the health check mechanism. Then what it will do, it will take decision to route the traffic to the healthy instances, not to the powered off or shut down or having the one which is having issue, not to that one. So we need to configure the health check so that load balancer send the request and check it, check their status, test their status, whether it is healthy or not. So there are a lot of advanced health check options also. We'll check the port. Okay. And it will see after how many timeout, if it is sending the request, sending a packet, and it is failing after 5 seconds, if there is no response, it will declare as unhealthy. All these things we can create here. So we will select everything as default. So my load balancer, okay, that's this. I can give any name, default, and click on create. So as of now, I am creating a target group, but I should have instance already. So as of now, I don't have any instance. So either I can create it and then add it to the group, target group. So I need to create an EC2 instance. I'm not going to do all the demo. I'm just showing you what and all option and how it works. So simplify it again, like you should have two EC2 instances in different availability zones. You should have a public subnet. You should have security group. You just go and create load balancer.
It should be two, or it should be more than two.
More than two also possible, based on your availability, that criticality. If you want highly available, you can create it 4 different availability zones, 3 availability zones, but minimum 2 is required, right? That is the whole purpose. If it is only one, why? What is the purpose? Where it will route the traffic? You should have backup plan, you can say. So minimum 2, at least it is mentioned, not at the max. So at least it is mentioned. At least 2 should be there, right? Can be more than 2 also, no issues. But keep in mind, like the more number of instances you have, although it would be more highly available, but it will charge you more, right? So you have to keep a balance between high availability as well as the cost. You have to consider the cost also. So that's how we will set up the load balancer. So what is a load balancer again? These are diagram, the client application load balancer and different availability zone. Here we have 3 different availability zone. Step-by-step guide. You can follow this. First, create a target group. You can create an instance and add it to the target group. Then application balancer, and in that, just add the target group. So you have instances in different availability zone. and you created this TG, I can say in short form, target group. This is instance 1 and instance 2. Both are in different ability zone, but they are part of same target group. So this target group you can add to, uh, you can mention in your load balancer. So this load balancer will know that these are the instances in which traffic need to be routed. Always deploy best practices, deploy targeting multiple ability zones to make it highly available. You can also use auto scaling group with target group for dynamic scaling. I will discuss what is auto scaling. Enable sticky session if session persistence is needed. Regularly review health check setting. So health check setting need to be considered appropriately. So in order to understand this load balancing thing, if you want more clarity, I have taken here an analogy, as I always explain things using the analogy to make it easy to understand. Imagine you are running a popular restaurant with multiple chefs. Chefs are the people who cooks the items, meals, whatever in the kitchen. Customer are walking in rapidly placing their food order. So this is a restaurant. It is example your web application. A restaurant manager is, for example, a load balancer. This guy manages everything in and out from customer to the kitchen, what's going on, and all those stuff. So it's the responsibility of restaurant manager. In our case, it's the responsibility of load balancer, where to uh, arrange the table. So customer will say, where should I sit? The customer will tell, okay, go to first floor. We have table free uh, available. Can sit there to eat the food. Ground floor is full. You can go to first floor. So these chef you can understand similar to EC2 instance, our EC2 instance, who are basically having the applications, which is the application are running on EC2 instance. And this order is like traffic request. So each customer, whenever they come, they give an order. So it's like incoming request to the restaurants. So it can be some order coming via online Zomato and Swiggy, online order, some offline, like people who want to uh, dine out, like they want to eat in the restaurant. So those type of request will come. So here order is like incoming traffic request. So here again, restaurant is your application, your web application. Okay, chef is EC2 instances, who is cooking the meal here and who is preparing it. Restaurant manager is like a load balancer who will route the traffic, and orders are like incoming traffic. What does the load balancer do or the manager do when customer walk into a restaurant, right? When the customer is accessing your application, they don't go straight to the random chef. Randomly, they will not go to any chef. Instead, that restaurant manager takes the order and assigns to an available chef based on who is free. So let's say 2, 3, 4 or multiple chefs are there to cook the food. Then it's the job of restaurant manager to see who is free. Here we have health check in our scenario, right? So it will based on the health check who is having more load, who is already having 10 order. So this guy is not available. Let's go to another guy who has the least load, who is free, who has the least load. So load balancing algorithm in the behind the scene will work. What kind of order it is based on content based routing. So that also if some chef is specialized in North Indian food. If customer is asking something related to North Indians, then they will route it to that. If some customer is asking for idli dosa, South India based food, then they will route it to someone who is specialist in that. So based on that requirement also they can route the traffic. So example one, application load balancer. ALB is like a smart manager who reads the order slip and decide if it is a vegetarian order, send it to the chef A. If it is dessert, like any sweet, go to chef B. If it is beverage, like some cold drink or anything, go to chef C. Path or host-based routing levers in application logic. So this can be chosen for routing algorithm. Example 2 for load balancer. So this was for application load balancer. It would be based on path or host-based routing. In case of network load balancing, is like lightning fast receptionist who does not care what's on the order, just that it reaches the kitchen as fast as possible, raw speed and performance. So this mechanism, network load balancer, does not care. It will just route the traffic so that it will quickly get their request fulfilled. It will always like a security officer in the restaurant. So every order passed through them first. They scan it, security appliances before forwarding to the kitchen. Inline inspection, perfect for firewall and third party. Let me discuss. Gateway load balancer are for firewall and third party appliances to route the traffic. Without a restaurant manager, what will happen? Without a load balancer, order might all go to one chef. One chef get overloaded, and in our case, one server get overloaded. Go to a sick chef. So if something is not good with that chef, if something not good with some application or instance, it will not be able to serve the request. Confuses the chef. Wrong routing. Right, wrong routing. So if in this example, if somebody needs some vegetarian and somebody is expert in vegetarian, chef A, if they get order for non-vegetarian dishes, it would be difficult for them. So similarly, here wrong routing will happen. Summary. So load balancer is like a restaurant manager. We distribute the request, right? EC2 are chefs who serve the traffic, and target group are like kitchen team, group of chefs, right? And listener rules is like menu sorting, path host-based routing, right? Health checks like chef checkup, only healthy servers serve. So whoever is healthy will serve. Auto scaling is like hiring chefs. Add remove server as needed. When the peak demand is there, they will hire more during the festival season and anything. So auto scaling thing will be there. Okay, we are done with this first topic of the day, load balancer and its different type, and we have also seen in the console how you can create a load balancer, how you can create a target group, how you can configure the listener, all those stuff. Next is auto scaling. Auto scaling is a powerful feature that automatically adjusts your cloud resources, for example, EC2 instance, to meet demand, ensuring performance and optimizing cost. It automatically adds or removes resources based on your defined condition. If CPU load increases, it will add resources. If CPU usage decreases, it will delete the resources. Key benefit: improves availability, right? Maintains performance during high demand. It reduces the cost. Scales in during low demand to save money. Automated, no manual intervention needed once policies are set. So I will explain this auto scaling like that. So you have some application hosted on instance, and there are certain users. Similarly, if during peak time, for example, in case of IRCTC during Tatkal booking process, thousands of users logged in at the same time, and that is a peak time, and they will increase the load on the application website, ICTC website, right? So this particular individual instance might not have that capacity to handle all the increased traffic because we have a lot number of users connected to it, lot number of requests coming in at the same time. So CPU utilization increases, RAM utilization increases, other thing. So there is very high load. So in this case of auto scaling, what will happen? It will automatically create similar kind of another instance. If more load increases, it will increase again. It will create another. So this is called horizontal scaling. It can be vertical also. Vertical means within the same, if it is 100 GB, it can go up to 200, 300, but it has on limit, right? So it will horizontally scale. So let's say initially it was only one instance and now it is up to 10 instance maybe, right? And as soon as the demand goes down and there is very less user active and the load is decreased, what it will do, it will shut down and delete the remaining one. Now it is coming back again to 1, from 1 to 10 and then 10 to 1. Will decrease the number of instances. That's how it works. Automatically adds and also removes. Right. So it is automated. That's the benefit of cloud. That's the beauty of cloud. You are sleeping, and if any load is increasing in your infrastructure, if you have configured it properly, you are using auto scaling, it will handle all the traffic. Otherwise, an alert is generated, L1 team will monitor the alert. They will ask L2 and L3 team to include the CPU and memory. They have to do manually, right? But in case of cloud, automation is there. Auto scaling will help. It will automatically increase and decrease and also save the cost once it is not required. And in case of manual, once the load decreases, you have to manually delete the instances, shut down the instances, right? Here, it's not required. It will do it automatically. So what are the component? Auto scaling group. It is a logical group of instances managed together, which have same purpose, right? So number of instances in a group is called as ASG, auto scaling group. Auto scaling group. Launch template defines how to launch new instance. So whenever from 1 to 2, 2 to 4, or whatever number of instance need to be created, it should know what and all configure it need to be there. It should be having all should be having same kind of operating system. What is Windows? All should be Windows. All should have similar kind of configuration. So you can define the template. So you just create a template. It will take help from the template. Based on the template, it will create multiple copies of the same instance. Scaling policies, rules. You need to define the rule that determine when to scale in or out based on the CPU usage. If it goes up to 90, you can define the criteria. Scaling policies, right, are the rule. Desired capacity. You need to mention number of instances the group tries to maintain. So it should have certain limit, minimum and maximum. Like it should not create thousands of server. Should have certain upper limit. Within that range, it can create the instances. Right? Minimum, maximum, need to set the limit. And desired capacity is instance that number of instances you maintain in at particular time. So you know it, what is your average load. So what is the average number of instance you want? So you can mention that. We'll see what and all these options are there. So there are 3 types of scaling: dynamic, predictive, and scheduled. Dynamic is automatically adjust based on matrices like CPU and memory. We can mention criteria. If CPU goes up to 100%, then if your CPU goes to 95%, scale up. If CPU goes below 20%, scale down. Similarly, memory also. In predictive use machine learning to forecast and schedule capacity changes in advance. So it will automatically learn based on the forecast, like in next few minutes or 1 hour or at particular time, the traffic generally goes up. So it will learn and it will automatically increase the capacity, increase the number of instances automatically in advance, so that there is no impact to the user. Before traffic comes in, based on the forecast, it will learn and it will help to increase the capacity. Schedule scaling is scale based on a predefined schedule. For example, scale out every Monday. So every Monday, user logs in early morning. So it is expected traffic will be there. So you can schedule it during this peak time, always schedule it. So always increase. So use cases, your website gets more traffic during the day than the night. Obviously, you set the policy add instance if CPU goes 70% for 5 minutes. Remove instance if CPU is less than 30% for 5 minutes. The rest of the thing will be handled by this. So first of all, you have to have a launch template. Create one with AMI, with a machine image. Mention the instance type and mention the key pair. All those stuff you can define in a launch template. And create an auto scaling group wherein you will define minimum, maximum, and desired capacity. You will attach scaling policy, define the policy like based on the CPU or based on the RAM or whatever, or some other alarm also. Use a stress tool to simulate high load. So for lab, you can use certain tool available in the market. Using that tool, you will increase the load basically on that server, so that you can see auto scaling in action. Once using that tool, you will generate a lot of traffic, so it will lot of load, it will automatically, you will see instances scaled up. Optimize for performance plus cost. So here is the benefit of performance as well as the cost. Why cost? Because it will automatically scale down also when not used. It works for EC2 cluster, DynamoDB, Aurora is also a database, Spotfleet is setup requirement. You need to launch, create a template and scaling policy and grow. So that was all the theory about scaling. So another example for this one is smart restaurant staffing. Imagine you run a restaurant that gets more customer during lunch and dinner, but is quiet during off hour. Without auto scaling, you hire 10 staff all day. Even when there are only few customers, you always have 10 staff. If you are not using auto scaling option, 10 staff is always there. And even if only few customers, all will be there. Wasted money, staff mode or efficiency. What will happen when you do the auto scaling, which means smart restaurant, right? You use a smart staff scheduler. 12 to 2 p.m. lunch rush is there. You add more waiters. 4 p.m. slow, reduce the staff. 7 p.m. dinner rush, increase staff again. 10 p.m. closes, send most staff home. So based on the shift also, right? So in our office also, in corporate world also, we see if the customer is of US, right? So during US peak shift hour, we will have more number of people. But during weekend, we will have only one person on call because there is not too much incident, not too much tickets are created, not too much meetings are called and other stuff, right? So during weekend, we will have less staff available in the office. Only one person will be handling the entire infra. During night shift, only one person. During day shift business hour, we have 3 or 4 or 5 people available in the shift. So based on the condition, the load, so this is called a smart restaurant. You have people in different shift. You hire the waiters for rush hour. So they will work only for, let's say, 12 to 2 p.m. or 11 to 3 p.m., whatever, 3, 4 hour slot. Part time they will do. Smart scheduler monitors customer load and adds remove staff automatically. So customer are like incoming traffic or the load. Waiter and chefs are basically the instances, EC2 instances. Smart staff scheduler is like a auto scaling group. Auto scaling group is like smart staff scheduler. Number of staff is equal to the desired EC2 capacity at particular time, how much I want number of instances. Customer crowd monitor is like cloud watch matrices. This particular service will help us to monitor the CPU percentage load increase, right? So there would be certain mechanism in the restaurant which will monitor the crowd. Staff hiring rule, when to hire which staff. So it is like a scaling policy, when to scale up and scale down. Restaurant hours is like schedule scaling, which is predefined. We already know that this particular is a dinner time. So during this time, they will more people, so more staff is required. During 4 p.m., it's not in between breakfast and lunch, so we have very less requirement. So this is called a scheduled one, scheduled scaling. Just like a restaurant saves money and maintains service quality by adjusting staff dynamically, auto scaling also help us to maintain performance under load, save cost during low usage, and avoid manual intervention. So you can do the lab for this one also. First of all, create a launch template like we have done earlier. We will go to EC2, create launchpad template. You can mention Linux T2 pair. We will select existing network as a default launch. So launch template first need to be created. After that, create an auto scaling group. I will show this. I have not shown you this one. We have already seen, but this one we have. So let's go to console. Here you can see auto scaling groups. Give it a name. Select the template. So the scaling group should already have one template created for it. Then network, then load balancer if you want. Okay, if you want, you can select the load balancer also. Instance setting, you need to mention desired capacity 1. Always 1 should be available, minimum and maximum. Next, then consider the health check also. Helps maintain the availability of your application, right? So how would it work? Auto scaling group have multiple stances, minimum, desired, maximum. Scale out as needed, right? So under EC2, at the bottom, you can see auto scaling group. Okay, create. So these are step 1, choose the template, choose the instance and launch option, integrate with other service, configure group size and scaling, add notification tag and remove. Specify a launch template that contains setting common to all EC2 instances that are launched by this auto scaling group. So for example, my auto scaling group ASG. So as of now, I don't have any, so I can create a launch template also. We need here, it will always select that. key pair, my key pair, subnet. Select anything else. They should not apply for to scaling. Okay. I think I have to create my own subnet first. Or let's say we don't include as of now, just for demo purpose. So launch template is created now. Should list here. So it got listed here, right? I'm creating auto scaling group. First option is I have to select the launch template. I have selected this, right? So it will give me all the detail. Next, and need to select the network availability zone. Define which availability zone and subnet your scaling group can use in the chosen VPC. For most application, you can use multiple availability zone and let EC2 also balance your strength across the zone. So why we should select multiple availability zone? For high availability. Okay. I selected 2. So availability zone distribution. How to distribute between these two? Auto scaling automatically balances strength across availability zone. If launch failure occur in a zone, select a strategy. Balance best effort or balanced only. If launches fail in one availability zone, autoscaling will attempt to launch in another. If launches fail in one availability zone, autoscaling will continue to attempt to launch in the unhealthy availability zone to preserve balanced distribution. So both options is here. So best is this one. If it is not, if it is failing in one, try another one. Try, do not attempt in same again, right? Next. So integrate with other services. Either you can use the load balancer or you can do without. Traffic terminal will not be fronted by a load balancer. So either you can go with the load balancer or without the load balancer. For simplifying, we will not select this one as it is default. So group size, set the initial size of the automation after creating the group. You can change its size to meet demand either manually or by using automatic scale. Desired capacity type, right? So specify your group size. So this is your desired one. So it will create that number of instance, whatever you mention here. If desired is 3, it will create 3. You can resize your group manually automatically to make it. Minimum desired is 1, maximum desired is 2. Go beyond 2. So choose whether to use a target tracking policy. Okay. Your tool will remain as its initial size and will not dynamically resize. And I want to use this policy to scale up and scale down. So control your severity during instance replacement. This will help checking. Okay. So there are multiple options. Send notification to whenever issues call launches or terminate the instance. So if you configure the notification every time there is a instance is launched or terminated or failed to launch or terminate, it will give a notification, right? So you will be aware automatically when it has scaled up and scaled down. So this is the final review, whatever setting you have set. So in short, you are simply creating a launch template, creating an auto scaling group where you will have this particular launch template, right? Create a policy, right? And you can then test it, simplify. You will click on it and it will be created. That's how it is done. Any question? No question. Then
Mm.
okay, no question. Then that's all for today.